Anyone remembers how we determine in this interval, how do I determine x bar? Last time we determined p. It was proportions, of course, so this is not good. So how do I determine x bar and how do I determine e, the margin of error?
I know that E is upper bound minus lower bound.
Careful. We add these two to get the right in the middle number. We add them, 28 plus 22, and divide it by 2. So that's 50 divided by 2, which is 25. So this must be exactly in the middle. And it is. How many units away from 22 and how many units away from 28?
3.
That's it. So one more time. We add these two, divide by 2 to get the number right in the middle. The distance between 25 and 28 or the distance between 22 and 25 have to be the margin of error. Same thing.
Right, but for E, couldn't you just do the upper bound minus the lower bound as well? If you didn't have the mean?
To divide by 2.
Yeah.
And divide by 2, yes. But don't forget to divide by 2. I agree. Okay, so the point estimate is 25. And the margin of error is, what did we say?
3.
That's it. Good, moving on. Who would like to continue?
I'll read this.
Yes, please.
Researchers studied the mean egg length in millimeters for a particular bird population. After a random sample of eggs, they obtained a 95% confidence interval of 45-60 in millimeters. In the context of the problem, which of the following interpretations is correct, if any?
Good.
So we are 95% confident that it would be between 45 and 60. It's one of those two, so it's either B or D.
Exactly. So it says the confidence interval, the 95% confidence interval. So we selected, we are 95% confident that the mean length of eggs for this particular bird population is between 45 millimeters and 60 millimeters. We do not use the word sure. We cannot say that all birds, no. We're 95% confident the mean length of is in the sample, no. So this is true. So we're 95% confident that the mean length of eggs in the sample, no. We're talking about estimating the population with the confidence interval. Very good. Awesome. Moving on. Okay, let's continue. Who would like to work on this? I don't know why I wrote 8 in there. Who would like to continue?
Reading the question?
Yes, please. Let's do it.
Use technology and the given confidence level and sample data to find the confidence interval for the population mean. Assume that the population does not exhibit a normal distribution.
Okay. So first of all, the data in this problem, we have 98% confidence, so 98% confidence. Then we have n equals 51. Then we have x bar equals 3 kilograms. Then we have the standard deviation 5.5 kilograms. Okay, what is the confidence interval for the population mean? Okay, so we go to and then I would like to explore the StatCrunch. So stat tests, and we want a t interval, number 8, with stats, and we have x bar, 3. We have standard deviation, 5.5. And we have N51 and 98%. And calculate. So we have the confidence interval, 98% confidence interval, 1.1491, 4.8509. Okay, so let's see StatCrunch. It will mess me up again, right? It always does.
No, you're in the screen now. That button right there that says get more help will keep you on this screen. No, on the homework.
On the homework.
Look at the bottom.
Oh, at the bottom, I don't see it. Okay, I see it now. Okay, thank you. This one. Okay, so if I click on this and it takes me to my StatCrunch or not?
Oh, I guess since you're the professor, it won't do it.
Sometimes it will, sometimes it won't. It depends on the problem.
Okay. So let's see if I can do this and go to the main menu and StatCrunch. Maybe I can go back to it. So this time we have to go to t-distribution. Degrees of freedom always n-1. So stats, let's see what this does. No, I don't want that. I want it with summary. Okay, and I want the confidence interval, and I wanted it to be 98, they said. And I want the sample mean, and that is 3. I want the sample standard deviation, which is 5.5, and I want the sample size, which is 51. And compute, please. And we got the same thing, 1.149, blah, 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 4.8509, blah, blah, blah. Okay? So, oh, I didn't mean that. Where am I? Why is it doing this to me? It's gone. It cuts me off every time I go to StatCrunch. And you know now it's going to give us a different problem, right? We have to check with StatCrunch when we finish, so I'm going to make a note of that. Okay. Which problem were we on?
It was number 9.
Okay, thank you. Thank you. Okay, of course. So I have to perform the calculations again. So the 98 is the same, 51 is the same, but now the mean is 4 and 6.4. Okay, 1.8462, 6.1538. One decimal place. Okay, so then 1.8 and 6.2. Okay. Is this confidence interval affected by the fact that the data appear to be from a population that is not normally distributed? Affected by the fact that the data appear to be from a population that is not normally distributed. Okay, so let's think. This one does not exhibit a normal distribution. Well, Yes, because the sample size is not large enough. No, because the sample size is large enough. It's a magic number, 30. It's over 30. Okay. Since we constructed the 95% confidence interval, can we continue? We'll come back to 10 if we need to. Let's see what else is there, and we'll come back. Yes, I think we should work on this one. So let's read it first and take notes. So lowercase n is 27. And the mean, x bar, 32.1 in minutes. Standard deviation, S, 7.2 in minutes. Assume the population is normally distributed and use a t-distribution to construct a 98% interval for the population mean. What is the margin of error? Okay, so then the margin of error. And interpret the results. Okay, so let's work on this and give me some answers. I will do too. Let's see who's coming up with the correct answer. We're constructing a t-interval using the stats, and it's a 98% confidence interval.
I put it in my calculator and I got the answers for the interval.
Very good.
The lower bound is 28.666, and the upper bound is 35.534.
Let me check my numbers because I got something else. I got 23 and 30. Let me look again. So x bar, yeah, I put 27. 32.1 and 7.2 and 27. Yes, yes, yes. So you got 28.666?
That is correct. And then 35.534.
35.534. Very good. That's what I got. Did anyone else get something else?
No, got the same thing.
Round to one decimal place. Thank you. 35.5. Good. What is the margin of error? Who would like to give us the margin of error, or at least tell us how to determine it first? How do I determine the margin of error?
Do the upper bound minus lower bound divided by 2.
That's it. Let's do that. Let's do it like that. That's fine. So 35.534 minus 28.666 divided by 2. That would be the margin of error. Good. So 35.534 minus.
I got 32.1.
But it's the subtraction. Careful.
Oh, I added. Sorry.
That's okay. No worries. No worries. We should certainly hope that the margin of error is tiny, right? So did we get 3.434? Anyone confirms that?
I got 3.4. Yeah.
Yes. So the round to one decimal place. Very good. So 3.4. Oops. We always want the margin of error to be as small as possible. Okay. Who else would like to contribute today for this part, A, B, C, D? So remember the word confident.
Okay.
Or confidence, right? So careful. So if a large sample of people are taken, approximately 98 of them will have to commute blah, blah, blah. No, that's not what the interval says. I am 98% confident, or with 98% confidence, as another way of saying it, is between the bounds of the confidence interval.
Okay, so
I'm pretty sure it's D.
Okay, so we're going to get to the in a second. It can be said that 98% of people, that's not. With 98% confidence, it can be said that the population, exactly, mean commute time is between. It can be said that the commute time is between this and this. Population mean commute time. Great job. Okay, so let's see the next one. A simple random sample of size n is drawn from a population. Okay. This is a discussion of the width of the interval, and I want to talk about it before we work on this problem, so you understand the difference. Okay, so let me start here a new video. So